Welcome to my YouTube channels. So today we are going to cover the unit 1 strength of material thermal stresses. The topic is thermal stresses. So thermal stresses already if temperature will change, elongations will come or contractions will come. So this theorem already previous video already we uploaded. So how to remember the stress and strain formula, that only I given very simple techniques. So suppose you see here, suppose one bar is there, length L. Suppose temperature increasing 30 degree to 50 degree, what will happen? Body will elongate delta L. If again temperatures will come back 50 to 30 degree, body will contract. Body will contract. That means temperature once will decrease, body will contract. But what we are seeing this diagram and this here, free elongations is there. No obstructions will be there. We are not stopping that block to elongate. So if elongations will be free, then stress will not develop. Stress will not develop. Now what we are doing here, we stopped both sides. So now you see same temperature 30 to 50 degree will be there. That means temperature increases. That means body wants to elongate. Body wants to elongate, but due to this fixed, the body they are pushing inside. That means compressive stress will develop. If stopping, suppose you are not stopping, elongation is coming, tensile stress coming. But here we are stopping, so body wants to go outside, but due to this fixed body coming inside, that is called compressive stress develop. But if temperature again reducing 50 to 30, that means this block wants to reach here because the contractions will come. So due to this, body will get tensile stress. Body will develop tensile stress. So how to remember the formula? Mainly here. Suppose change in length depend upon the temperature difference in length. What I wrote here, temperature difference in length. Change in length, elongations, it depends on change in temperature into length. Suppose this proportional will remove, it will come linear coefficient, that alpha, that is called, I am taking alpha, that is constant, delta T into L. Now change in length we know. So what is strain formula? Change in length to the original length. If you will substitute both, it will coming strain formula alpha into delta T. So coefficient of linear expansions. What is this one? Coefficient of linear expansion. Stress means, Young modulus is equal to stress by strain. So stress is equal to Young modulus into strain. So this is the formula is coming. Two formula is coming. Now special case what is there? Suppose you are stopping to the end only. Suppose you are stopping here end only. Now what will do? Will not stop in the end. After some distance will stop. So what will happen? Body will elongate up to this if temperature will increase. But due to this fixed part, body will elongate up to delta only. So that is called a special case. What is the formula? Change in length will be alpha delta T L minus delta. So this way we can substitute strain and stress. So we can get the formula. So that problems I will solve. So in this problem that formula again I will write. So what is this problems they given here? A steel rod 3 cm dia is there, 5 meter long and connected to the two grips, and the rod is maintained at a temperature of 95 degrees Celsius. Determine the stresses and pull exerted. Two things they are asking, stresses and pull exerted, that means P, pressure. Two cases, when temperature falls 30 degrees Celsius. What is the two cases? The end yield, end do not yield, and one cases end will be yield up to how much? 0.12 centimeter the given. And as usual Young modulus and coefficient of linear expansions value given. So now how we will solve this question? So what is given data here? Dia the given. Dia the given means area we can find out pi by 4 mm na 30 square. So this value will get now mm square. This value will get mm square. So this value already we calculated. Area will come 225 pi we wrote as in terms of pi. So area we know now. Now what we'll find? Case 1 will find out. So directly we'll write the formula for the stresses. Case 1. What is the stresses formula? If we'll take the stress equal to E linear expansion into change in temperature. stresses, Young modulus, linear expansion into change in temperature. We will substitute all the value. So what is the 2 into 10 power 5 and mega is 10 power 6. So we can write 2 into 10 power 11 into linear expansions 12 into 10 power minus 6 and length E delta t how much given fall in temperature 95 minus 30 degrees, so it will come 65 degree. So this value will come, already we calculated, so this value will be there 156 Newton. First you write in mm, 156 into 10 power 6 Newton per meter square will come, Newton per meter square. If we will keep into kilonewton or mm square, you write na 10 power 6 56, because mm square na 10 power 6 it will go, it will get cancelled, because if you convert into Newton meter square equal to 156 into 10 power 156 Newton per mm square will come. So this is stress we know. Now what is they are asking? Pull, that means P. P is equal to nothing but stress into area. Stress into area. So we will substitute this value. Stress how much? 156 Newton per mm square. Then area also in mm square. 225 pi. So this also Newton mm square. This also mm square. So it will come Newton. How much Newton is coming? 110.27 kilonewton. This case 1 came. Now case 2 will be there. Yielding. Once will be yield. Then what is the stress? So stress formula will write stress equal to E alpha T. But what is this change? What is this change in length here? Minus delta. So now we write this formula. How we'll write here? Stress equal to change, stress equal to strain. First you find here. What is strain equal to in that case? Strain is equal to change in length by original length. What is change in length here? Alpha E. Okay, E is there, no? Young modulus. E alpha into delta T minus delta. So this delta only, because this is special case. By change in length. By change in length. So okay, so change in E alpha, what was strain? No, change in length. Change in length E alpha T into L. E not be there. Just 1 minute. So change in length, what is same things will write here. Change in length nothing but this alpha linear expansion, then delta T into L minus delta by L. This is coming what is? Strain. Now what is the stress? Stress you know E into strain. E into strain. So what is E here? E we wrote, and strain this will write here. Thermal expansion delta T into L minus delta by L. So this value will, this formula will come for when? Case 2, when the int L 0.12 centimeter. So this delta value will be there here. How much? Delta value they given 0.2 centimeter. So if you convert into this all value, we are writing either Newton meter square or Newton mm square. So according to this you can convert 1.2 mm. If you substitute all the value, if the substitute all the value given here, L we cannot cancel because L is this minus delta is there. So L will not cancel. So this value will come 108 Newton per mm square. If you substitute this value will come, stress will come in the case 2. Then load again similar case, what will come? I will write here now. I will write this part. And what is the load will come here? Same. What is P? That is called pull exerted. So P is equal to stress by stress into area. So what is stress we are getting here? 108 into area will be same 225 pi. So in that case we are getting 76.34 kilonewton. So here we are getting 110 kilonewton. Just will highlight this. So this case 1 pull this much, this one 73.31, and stress develop 156. This is answer, and stress develop in case 2. So these are the answer. These are the answer for this particular problem. So if you know this concept, how to formula is coming, write the formula, and you can get the answers. Okay, students, watch the video and subscribe the channel. Okay, thank you.